Okay. Hello, sir. DAD office requesting if you can start the meeting.
Good afternoon, Karan. Sir, can we start the discussion?
Affirmative. I think the sequence is not correct. First, we'll go by the sequence of digital NVG first, as we've given out in the tweet. Karthik, that's a Aditi problem statement. We can shift to that one first.
So that is helmet mounted digital night vision device.
Correct.
Done. We'll start with that, sir.
Right.
We'll share the problem statement and then. Requesting, is our screen visible?
Yes, it's visible.
Okay. So good afternoon, everyone. A very warm welcome to the technical outreach session for the challenge under ADITI 4.0 and DISC 14, organized under the IDEX framework. So I am Sthiti and Karthik from my team joining from the DIO today. So just to give a brief, total number of 208 problem statements have been recently launched by the Honorable Raksha Mantriji, and which represents a tremendous opportunity to develop indigenous solutions that will strengthen our armed forces and to propel Atmanirbhar Bharat in defense. So, out of those challenge and prompt statements, in today's session, we have a total number of 3 challenges, 2 from the DISC and 1 challenge from the Aditi. So the Indian Air Force will be providing technical insights and deeper understanding of the release from statements. We are very privileged to have nodal officers from the Air Force with us today. So we will guide through the details. Requesting to you, sir, if you can start.
Okay, thank you.
Pat, sir, over to you.
Okay, thank you. Could you scroll down a bit, please?
Sure, sir.
Okay, hi, good afternoon, everybody. I'll be covering the problem statement and a little bit of detail in terms of some genesis and why we are doing this and what exactly do we desire. Any questions that you have can be asked subsequently during the discussions. The title of the challenge is helmet-mounted digital night vision devices. As you're aware, the IAF uses the night vision devices in fighter aircraft, in helicopter aircraft, in transport, as well as on the ground by the special forces. So night vision devices help us to, of course, see better by night. And since we can see better by night, we can fly better or we can fight better by night. We can see the terrain and we can see other things as well. So that helps us to orient better and fly. Now, this technology is based on microchannel plates, that is image intensifier tubes for all those who are from this particular field would know. And it is mostly, you would have seen it in the form of binoculars. So it has certain limitations as it is a fairly old technology which has sort of reached its technical limitation. And the better performing night vision devices which are available in the market are mostly export controlled, and we don't have access to that market. So the objective for us is to create in past was to create a night vision device using the existing technology of image intensifier tubes. However, what we saw because of the advent of mobile phones and the camera technology, overall sensor performance has increased quite significantly. So then we switched gears and we thought that let's take a step forward in future, and instead of going for a regular NVG, let's try and foray into the grounds of digital NVG, which has a lot of advantages, of course, and it would also allow us to do a lot of things in the future, since the information available to us would be in digital format rather than in the analog format as would happen in a regular NVG. So our aim would be that the mandatory objectives that we have would be, of course, to make a helmet-mounted digital NVG device. And the device could use any type of sensor. It could use CMOS or any equivalent digital sensor, basically. Aim would be to amplify the light and show the image to the pilot on an integrated display. The display could be an external display, it could be an integrated display. I'll touch upon that subsequently into my presentation on my slides. So to give you an example of what kind of technology is already available in the market. Okay. Now, flying helmet per se is a technology in itself, just the helmet part of it, and mounting something on it is quite critical. So we are not here to reinvent the flying helmet part of it. So we will define the baseline helmet in the IF, what we use fairly commonly on most of the helicopters and fighter fleets in the Air Force. And we will use that, and we will build on that. So either we'll build a binocular on the helmet, or we will build on the helmet itself, sort of a helmet mounted display system. That also option will be available to the innovator, which direction they want to foray into. But the aim would be to at least stick to one type of helmet, so that we develop the technology first, and thereafter we can graduate on to other type of helmets. The device needs to be binocular. That means if you are going for a binocular version, then it needs to be binocular, or otherwise it could be based on a camera tech which is fixated on the helmet. However, the image that is available to the pilot is a stereo image. And of course, needless to say that this whatever technology comes out of the solution and the product comes out of it, that needs to withstand the rigors of the flying environment in terms of temperatures, in terms of hot and cold temperatures, humidity, vibration, and those kind of things. So there is enough adequate literature available on those aspects, and we are here to handhold you to help you guide in the direction of what is required. In terms of very broad technical capabilities, let me first tell you that the existing NVGs follow a word which you might have come across as figure of merit. So figure of merit is basically a function of the resolution of the NVG and the signal to noise ratio. Basically, it's a multiplicative factor of that. And commonly you would hear NVGs which are available in civilian market to have about 1200 to 1400, at times 1600 figure of merit. And subsequently, export control NVGs are available above 1600, touching approximately 2300 to 2400. It is not heard to have NVGs more than 2400 figure of merit. So that is something that we are going to be looking at in terms of figure of merit. So while it will directly not be applicable to digital NVG part of it, but overall we would want to match the performance of the product that you're going to develop to NVG, which is with us of about 2300 figure of merit. Okay, so but if you would broadly see, it will work out to be a sensor resolution of at least 1280 into 1024 or better. A frame rate is very critical, especially in case of a digital NVG, because we can't have a laggy video being shown to the pilot, because it will straight away impact his ability to perform the task, or the special operator force chap on the ground. It will impact his ability also. Field of view minimum desired at 40 degrees. It could be wider. There's no problem. So a smaller field of view will have a penalty. So that's something which we don't desire. So spectrum of operation is important for us. So we're looking for at least 400 to 1100 nanometers or a wider image. If, however, there is some deviation to it, we're ready to discuss that particular part out. Now comes to once you have figured out how to use your sensor to generate a video, eventually it has to be displayed to the aircrew, right, or to the operator. For which we are okay with any kind of technology for display. We would try and avoid CRT to be very frank, because that is something which we have not had very great experience with over a period of time. And there's very few manufacturers available in the world, albeit or even including the parts and all, which will be available. So we can move towards the forward-looking technologies like AMOLED, micro LEDs, OLEDs, or whatever you guys are comfortable with. Minimum again resolution needs to be at least match the sensor resolution, or it needs to be better than the sensor resolution. I've mentioned a figure of 1920 into 1080, but it could be this is negotiable till the time it doesn't deteriorate the performance of the sensor. We are absolutely okay with it. Diopter adjustment will be applicable for innovators who would go the binocular way. So that helps the the aircrew with the different eyesight to adjust the binocular in a certain way. So plus minus 4 is a fairly common diopter adjustment, which is also available in regular handycams and even eyepieces of regular SLRs. We're looking at an eye relief for 25 mm of more, again for cases where we are going in for binocular type of development. A built-in compass, GPS, and 3D orientation sensor would automatically sort of get featured in, since it being a digital device, it will be much easier to implement. GPS is something which we can look at picking up from the platform, a facility to pick up from the platform, or a very sort of a solution available embedded into the system without impacting the overall performance. We're looking at least storage of about 14 hours of video on board. That is somehow matches very close to the performance of the aircraft that we have. And this again is manageable. We can see how we kind of go about it. When we talk about the video recording, we would want uncompressed video. That is the 14 hours of uncompressed, or if you've compressed it uncompresses back to the original recorded capabilities, original sensor capabilities. Okay. What the point number 5.10 is very important. We're looking for an onboard battery. That means this entire system needs to be independent of being connected to the aircraft. That means it should have its own battery. It remains on the helmet itself or inside the binoculars or on the binoculars. It does not require a connection onto the aircraft, because especially for fighter cockpits, it is not possible, because you must have heard about ejection seats in the fighters. So when the pilot does eject out, we can't have a cord of connected from his head onto the cockpit. That is absolute no-go on that particular area. So the battery has to be built in, and the battery has to last this particular thing. I can tell you very frankly that in the existing NVGs, the batteries run for upwards of 24 hours. So that's really not that big of a problem. Then quick disconnect mechanism is again applicable for innovators who go for binocular type of solution. There is what we are looking at is I would show you a photograph of a helmet and an NVG subsequently in my presentation. So when the aircraft ejects out, and so a pilot ejects out of a fighter aircraft, if the NVG does not separate on its own, using a quick disconnect mechanism, then this NVG is basically it moves the CG forward for the pilot's head, and the pilot's neck would snap down forwards, and that will lead to either decapitation or a very, very severe neck injury. So when we talk about fighters, quick disconnect mechanism for any innovator going the binocular way is a must, is an absolute must, and it's not negotiable. For helicopters and transports, this is fine because there is no ejection seat and we can make do without it. But for the fighters, it will remain an absolute go. Size, in terms of size and weight, we are looking at commercially available 4949 NVGs, which are American made. These are almost pretty much the gold standard of NVGs available anywhere in the world. And we are trying not to go over the weight and size limits of it, as if we do go over, then the amount of effort that will be required to qualify these NVGs for a cockpit is going to be quite significant, and getting certification is going to be quite challenging. So try and remain within the box, which is already qualified on the aircraft. It will be much easier to get the product cleared. And of course, as I had covered earlier with regards to environment survivability, MIL standard 810 is the one that we will follow. For all those who are not aware, don't worry about it. The MIL standard is available online. And once we do go through the HPSC process and you're on board, we will be explaining exactly what all will be applicable to it. May I request if the slide can be scrolled down? Thank you. With regards to mounting options, so as I had covered earlier, we will take the baseline helmet as the MSA Galley LA100. The company is MSA, the make is Galley, and the model of the helmet is LA100. There are a multitude of binocular mounting options which are available. So again, it is applicable only to the innovators who go the binocular way. So we will try and stick to the commercially available or the globally available mounting option, so that we are not reinventing the wheel again on the helmet part of it, so that the quick disconnect and other things are already kind of in place for it. So again, we will share the information that we have with regards to the mounting options as we move forward into our selection process. Now, coming on to what exactly can we do with it, as I briefly touched upon earlier, that this is a digital NVG. So the image is already available to you digitally, right? When you produce that image out of the sensor. So since it's a digital image, a lot can be done on it, right? So what we actually desire on it is, straightforward. It should be easy to overlay certain information or mission specific information onto the digital night vision video. For example, it could be the flight performance information of the aircraft. It could be certain mission information or regarding navigation. For a special force operator, it could be information regarding compass and target and those kind of things. Okay, that is why I had earlier projected that we would want the compass and the GPS at least to be embedded into the aircraft, into the system. Second would be an automatic detection of objects, shapes. If you would take an example, if an aircraft is flying low, close to terrain into the mountains, if you're able to see a hillside or a mountainside on the terrain, or at least the boundary, it should be able to sort of, if possible, highlight that thing to the pilot, or if it sees, another aircraft moving on, it should be able to kind of detect that and highlight that thing. So of course, we'll work on the nitty-gritty subsequently, but a sort of computer vision is something that we are looking at into this particular capability. Of course, it's a desirable capability. Our first emphasis would always be to have the sensor developed or the sensor adapted to get into the digital night vision foray. And subsequently, we can move forward on these points. If it's possible as a part of the project itself, nothing like it. If not, then at least we would like to see provisions for it. Okay. Second, now let me cover some existing solutions which are there. So as I've covered, normal NVGs are available. They have a lot of limitations, and in terms of digital NVG, there has been progress made in Europe, Israel, UK, in US, as well as a couple of private companies, both in military as well as in private domain. Okay, so we can, if you could please scroll down, please. Yeah. So overall, if you see, there is a lot of future in this particular tech, because most of the battle is nowadays, fought by night or in very low light conditions. And this particular solution will get adopted across the Airforce, across all platforms, across the special forces. So if we do get the product right, and if we get a good product, at the end of it, it will find wide adaptation within the service. And of course, it will be a good product to export outwards also, because again, the major product producers in the market are actually holding on to this technology, and they're not really eager to share it with everybody else. With regards to testing and certification, of course, the testing would be undertaken by the QA agencies, including Semilac and all. We would be doing a lot of hand-holding with regards to what all would be required. So we'll have a roadmap to go forward from there. And our objective would be to kind of remain within the box which is already qualified for today, so that we don't have to really do very, very extensive kind of testing, which may take years. So we'll remain within the box. That hand-holding we will do. And with that, we should be able to kind of minimize our overall certification requirements. Okay. With this, I have actually finished the problem statement part of it. Let me, if you would allow, I'll quickly skip to my presentation, so I can show a few solutions which are already available in the market and something that I have not spoken about.
Group Captain Victoria, please go ahead. You can share the screen and it's all yours.
Hey, hi. It's telling me that content sharing is unavailable for me, so you will have to allow me.
I'm just enabling that.
Okay, thank you.
You have to find his name.
Okay.
Okay.
Can you please check once now if you can do that?
Yeah, I think it should be available now. Yeah, okay. Okay. So I hope you're all able to see my screen now.
Yes.
Okay, great. Is the slide completely visible, or are you seeing an orange window on the slide also?
No, it's on full screen.
Okay,
Good.
Okay, so certain parts I've already covered, so I'll kind of skip with regards to my presentation here. So I'll briefly touch upon the issues that we had. So with the major intensifier tubes, they were pretty fragile and the technology is restricted. The photocathode is fine. The phosphor screen has issues with aging. So over a period of time, as the NVG gets old, the image starts to dim out quite a bit. The contrast goes, and that affects the figure of merit. The optics of the NVG, if you could see on the image on the right, they are very fragile, because they are, of course, mostly made up of glass. Now they have adapted certain plastics also, but at the end of the day end up being fairly bulky. They actually constitute the most weight on the NVG. The technology has reached its saturation, and of course, there are no digital overlays available. There are a few players in the market who claim to overlay digital information on NVGs through insertion of certain sort of transparent LEDs and then LCDs and then try and do that. But I have truly not seen a working model ever, though it has been promised to us, but I have never seen it. And the image is, of course, focused at infinity. So what happens if you would see the pilot on the right hand side who's wearing the goggles, when he's looking at the outside world through the goggles, because it's focused at infinity, it's absolutely fine. But if he has to look inside the cockpit, look at his instruments or his displays and all, since the goggles are focused at infinity and the displays are sitting close to about half a meter to 1 meter length, it's all blurry. So he has to see through the space between his eyes and the binoculars, which is called as eye relief. And it is a slightly sort of a different way of viewing the world, and it has its own challenges. So that is something which we would want to avoid with regards to this particular technology. This part I have already covered, that we would want you to have a sensor or adapt a sensor and put it into a goggle or adapt it onto the helmet. On the right hand side, if you see, this is the MSA Galley helmet, which is available with the Indian Air Force in white numbers. And we would want this to get adapted either as a sort of a helmet or as a binocular system which can attach to it. Absolutely fine with both the particular solutions. And we, of course, need to exploit the software to enhance the available image if required, to automatically detect objects and to overlay digital information. Okay, the last two being desirables. Okay, this part I've already covered with regards to both the solutions being available. So here is a few examples of stuff that is already under development or at a fairly advanced stage of development in the world. So what you see here is Striker 2, which is made by UK. I don't remember the company. I think it's BAE Systems. And if you would look at the helmet, in the center part of the helmet, you have the camera which has been embedded with a few additional sensors, and that is the DNVG, the digital NVG camera, which is there. And thereafter, the image gets projected onto the visor from inside, and the electronics are distributed. If you could appreciate, actually, the rear part of the helmet looks a little bit. The electronics have been embedded to basically counteract the CG, the center of gravity of the helmet, to have it as centered close to the spine as possible. And this helmet is right now on the a very advanced development stage. There have been a few contracts to get this by the European Air Forces. Second over here is LBIT 0G. So this is a JHMCS 0G helmet by LBIT. This is again as far as I'm aware, it is in development stage. This also uses a central mounted camera onto the helmet, not through a binocular or a monocular, and distributes the electronics throughout. And it is also, as far as I'm aware, it's in the development stage. Third, I'll just skip to a commercial solution which is available in the market. It's by a company called Sionix. If I remember correctly, it's an American company, and it has both handheld as well as monocular and binocular solutions available to us. They claim less than 1,000 milli. Forgetting the exact this thing, but they claim in starlight conditions with clouds, this device can actually produce an image equivalent to a figure of merit 2300 NVG. And the electronics are obviously integrated into the binocular itself. There is nothing else that is required, including the battery. This product is actually available for sale in the market with certain export limitations, which are not very clearly specified everywhere. Okay, with this, I have come to the end of my presentation. I will be more than happy to answer any questions or queries that you have. Thank you.
Thank you so much, sir, for the insights on the technical aspect of the problem statement. Now I request the innovators to kindly ask the questions. I request Mr. Manas, you may go first, as you have mentioned some queries in the chat.
Yeah, thank you so much. Good afternoon, Group Captain Pachari. It is great to hear from you, and a lot of these technical aspects that you mentioned really help us. So, okay, so the main question that I have is, when we talk about digital overlays, right? There are a few different technologies. One is like a VR kind of system wherein you just have a digital display in front of your screen with a few lenses to collimate the light and projector at a distance, and that kind of gives you the like the effect that you're viewing it at a distance. But the problem is it's not pass through. So if something goes wrong, then it's a blank screen in front of you. The second is something like a bird bath based optics. One of the visors which you showed in the presentation was based on that, wherein it's partial image which is projected, and partially you can see something which is in front of you as well. But this is not, again, the best of technologies, but it's one of the bulky technology which is there, like a prism based technology. Then there's another technology wherein we have waveguides, right? We use holographic or surface grading waveguides, wherein the light is internally reflected and you get a very a systematic image as an output. But again, your normal viewing is not at all affected. So it is completely pass through optics, and we make it on plastic or silicon itself. So yeah, like these 3 or 4 different options are there. So which is the technology that is currently being foreseen in such an application?
Okay, so very nice question actually. So see, we will not hold you sort of fixed to a particular technology. We will tell you what exactly do we desire in terms of output. So we cannot have the vision of the pilot obstructed. Okay, so any technology that if it fails or if the display is no longer available would make the pilot blind and not be able to see the outside world. That is something that will not pass muster. So we would go for a technology through which that we are able to view the outside world, and the video either gets projected or, like you mentioned, the way the other last one worked, the waveguide one worked. So the overlay is available to him, and in case the overlay is not available, the outside world is always visible and viewable to the pilot, not through a camera but through his own eyes. So that is something that is important for us.
Understood. Understood. Thanks a lot for that. Few follow-up questions,
Mhm.
and some unrelated ones as well. When again we talk about like these technologies, right? So bird bath is one of them, because like you mentioned, now it helps in clarifying that okay, it has to be unobstructed, right? Even analog, honestly speaking, it is obstructive if something goes wrong, if some of the lenses break or something.
Yeah.
But over here now, when we talk about unobstructive, we have bird bath optics, and then we have certain waveguide based solutions,
Yeah.
reflective, surface grating, or holographic based. Now,
Mhm.
over each one of them have got a pro and con. Like so, like for example, I'll just give a small example. Like a bird bath is bulky, right? And
Mhm.
the problem with bird bath is it has to be tinted heavily. If it's not
Okay.
tinted, then the display will not be visible very well. Now,
Okay.
when we talk about normal waveguides like holographic or surface grating, it's much more clearer. But the issue is there's a little bit of reverse eye glow. So if somebody or something is in front of you, there is a possibility of a slight leakage of light. So that could be something which is not again feasible from certain military aspects as well, right?
Mhm.
So these kinds of things, would they be considered later, or is this something that we can maybe get a bit of clarity on, like which kind of optics to proceed with exactly?
Yeah, so quite nicely actually put. So we are not, so we are mainly looking, I understand that any technology that we are going to use, it will, have a little bit of impediment on the headset. That means a little bit of tint and all will be there,
Right,
which
right.
we are used to having. So we have display and helmet sighting systems in the Airforce right now. Of course, it has the capability of projection of certain videos, okay, mostly infrared videos, or otherwise raster scans of our head mount head-up systems. So that information is available to us. When it is off, there is a little bit of tint that we can make out, but it really does not impact us so much. Second is, since most of the information is actually projected onto a visor, or like you saw in this particular case, there is always a possibility of raising up the visor and bringing down a clear visor on top of it, right? So if, let's say, one of the visors was tinted, you could raise it up if you're no longer using it, or if the system is defective, and you could roll down a clear visor through which is absolutely an alternate visor which does not have any obstruction, and you can like see through naked eyes irrespective of don't use the digital NVG altogether. So there are multiple options that are possible. We are not going to block you in terms of this. It should, our underlying statement is that it should not be obstructive. And with regards to bird bath, you absolutely rightly said. So it's fairly bulky in terms of that goes more into AR domain than in the kind of area that we would like to restrict ourselves into. Because the more bulkier you get towards the front of the head, you'll realize that the margin of center of gravity of a helmet that we have is going to be is fairly restrictive in the front. So as we move forward on this, we will handhold you on that particular aspect also. So there
Understood.
are a few documents which are available in the open source again. which kind of give a box sort of a thing with regards to weight and CG, how it can be for a fighter cockpit. Our primary use case is going to be fighter cockpit because that is the most restrictive. From there, then we can water down to helicopter or transport stage. So I am sorry, I'm not able to like 100% tell you because I'm not 100% privy to all the kind of technologies which are available.
Right,
But in my best opinion, this would be that don't make it too bulky in the front. Try and have it as rugged as possible, and try and not have it being an absolute obstruction. If it's becoming an obstruction due to something, it should be removable and easily. So this is
Understood.
something that we can kind of go for, like the classical NVG goggles that you see, which I showed, the one generation
Right,
which is
right,
there.
right, right.
So if it doesn't
Right.
work, we can flip it up, right?
Understood.
Yeah.
No,
So
absolutely. It makes
yeah.
sense. And this actually quite like helps, like the points you're mentioning, right? It helps us in narrowing down as well. So like just for some background, we are one of the companies in India which is making such waveguide optics from scratch. So
Oh,
after
great.
like 2 3 years in R&D, we have started making our own waveguides as well, just so that again we can have some kind of independence in this aspect, like globally. And now based on your specification, we can definitely customize and modify them. One small like again follow up is, are you only looking at monochrome or RGB based applications as well?
No, we are actually preferring to have color.
Okay.
Okay, but the entire spectrum of color may or may not be reachable, but it's not going to be a make or break situation. We are
Understood.
fine with having monochrome also if that gives us a better results. At the end of the day, we want a better figure of merit. We're not looking at, okay, if a black and white option or a monochrome option gives us better figure of merit, we will try and kind of go towards it. But we don't have a
Understood.
particular preference in it.
Right, right.
So
Yeah,
it could be
definitely.
like, sorry to cut you off.
Yeah, yeah.
It could also
Please.
be like it has limited color. For example, the image is monochrome, or having two colors, and there is an overlay possible on it with red and other important colors that we have. So that is something that you all can look this thing. We don't require 100% colored image. If we can get it, exceptional, nothing like it. If we can't, it's not a bank
Right.
breaker.
Definitely. Now, this also help because again, based on the field of view requirement that you mentioned and the resolution, certain constraints come into place definitely. So yeah, like this helps actually. One small last question from my side, actually quite a few, but last question because I think others would also have it. You had mentioned that it has to have some kind of quick disconnect feature, right? That you don't
Yeah.
want it to be connected to the cockpit in any physical manner. So
Yes.
as far as I understand, the battery, every sensor that is present, any kind of data that we'll be showcasing to the pilot has to be processed and developed on the device
Yes.
locally, right? Nothing has to be connected to the system as
Yes.
such over there.
So, see, this is mainly to sort of get our certifications in a sort of a faster time frame. Normal, like if you, let's say, want to develop a helmet from scratch, which is connected to the cockpit, then the technologies associated with it and the certification associated with it will take about 5 to 10 years, from anywhere from 5 to 10 years. Okay, the testing involved with that is quite significant. So you try and avoid all of that by trying to remain as much captive as possible, so that we are within that ecosystem is limited within that, and we are not connected with the cockpit, because then other complexities will arise. However, having said so, if it is becoming an absolute no-go that certain technology or certain solution is just not possible without having to go remote, then we would prefer a wireless remote option. That means you have a device which is there in the cockpit, which is doing the sort of a heavy thing for you, heavy lifting for you, and you can stream it wirelessly into the helmet. That is something which is fairly easy to get a certification with, but having a cord connecting from the helmet to the cockpit, you can consider it's a 5 to 10 years. I've been associated with that kind of a system before, so I can tell you that it takes a significant amount of effort to achieve it.
Understood. Absolutely got it. Sorry, again, just because you mentioned this one final question, you had mentioned diopter variation is required, right?
Yeah,
-4 to +4.
yeah, yeah.
So in that perspective, when somebody goes into the cockpit or somebody is wearing a helmet, is
Mhm.
it that it has to be fixed for a particular person at a particular time, or you want a extremely variable mechanism wherein at any moment of time it can be changed as per the requirement?
Yeah, so it needs to be variable. Okay, so
Okay.
what will happen is, if you would recall an SLR or SLR camera, in that the diopter is just, you can just pull it out, or you can just kind of rotate a dial and get your diopter
Right,
right.
right, right, right,
This will be
right.
more applicable actually for cases or for innovators who are wanting to go for a pure binocular sort of a setup, Wherein because the
Right.
binocular is sitting at a certain distance from your eye, you need that diopter mechanism for the pilot to adjust depending on what his eyesight a particular value is. But if you are purely going in for a digital projection onto a visor or something of that sort of system, then the helmet will get adapted to the pilot in a lab, and it can be fixed. It need not be fluid.
Understood. Got it. Yeah, this helps.
Yeah.
Actually, this is also quite relevant to us because when we talk about such waveguide based systems, right? When we are showcasing a 3D image at that time, we can kind of have a fixed image that we're projecting it at. But when we want to just overlay digital information without any kind of vergence accommodation issue cropping up over there, the optics slightly differs. So even color, monochrome, all of that kind of depend on it. But again, your answers help. So we got a fair idea, and yeah, we're looking forward to working with the IF on this. Thanks a lot.
Okay. We look forward to helping all of you out.
Thank you, Mr. Manas. Do we have any more questions?
Yes, sir. My name is Gagan. I'm from Chennai. I have a question.
Please go ahead, sir.
So, is there a scope of exploring a cognitive sensing approach wherein a perception layer AI interprets optical sensor streams in real time? To maybe generate an operator understandable perspective rather than relying on your traditional image intensification components, photocathodes or phosphorus screens and all.
Yeah, so we are not looking to get into photocathodes and phosphor screens and things like that. Absolutely no. That is not the direction we want to go into at all. We want you guys to
Understood.
put a
Yeah.
sensor, develop an image or a video out of it, and then project that image. Having processed, then project that image onto a device through or on a screen through which the pilot can see it.
All right.
And
So
if you
the
can
question.
process along with it with regards to the things that you just mentioned, we are great with that.
All right. So as far as the patent for the perception layer AI is concerned, will that be done beforehand, or is that to be done once that is being used?
I didn't get your question. Sorry. You'll have to
So
simplify. We're not that smart, yeah.
no. So sir, I'm merely trying to ask the question whether. So if we are submitting our if we're working on a perception layer AI, it's a model, and the model can easily be emulated. My basic question is basically to understand whether the patents for these are provided before it is being used in a proper setup, or once it's been used, and that's when you consider the patents and all.
Hi, Group Captain Pichori, I'll take this one.
Yes, please. I
Uh,
was pointing towards you.
yeah. So, acquiring the patents for your product is only up to you. What Airforce wants is the end product, and we do not indulge into any patenting process. It has to be done by you, and you can do it anytime you deem fit. I hope this
Understood, ma'am,
clarifies.
but
Yes, please.
it does clarify the question.
Anything else that you would like to ask?
No, that'll be all. Thank you.
Thanks. Any more questions, please?
I think there was somebody who raised hand, Madhu
Hi,
Trivikram.
hi, sir. This is Madhu. This is Madhu Trivikram.
Yeah, Mr. Madhu, please go ahead.
Yeah, sir. Thank you. Thanks for the nice description of the project. So from your presentation, what I understand is that typically these night vision goggles systems are export controlled primarily due to use of this microchannel plate technology. So are you essentially asking us, asking the innovators to develop these critical components within India, or or you want a solution? But what kind of indigenization you are anticipating?
Okay, so to answer your
Captain
question,
Pichori, yeah, just want to quickly say that Air Force shall procure as per the DAP procurement manual, which requires at least 50% of indigenized product. So please go through the manual carefully and see what level of indigenized products are required for procurement. Rest technical details, Captain Pichori, if you want to add something to this.
yeah, certainly. So as I've covered, we are not wanting to go towards image intensifier technology at all. We don't want to go to the microchannel plates. We don't want to go to the traditional NVG setup at all. We don't want you to develop it. Now coming to the digital NVG part of it with regards to sensor. So if you all can develop the sensor, absolutely perfectly fine with it. We have no restriction to it. Okay. But my understanding to this is fairly limited. As far as my understanding goes, most of the sensors available across various platforms, cameras, systems, and all are generally manufactured by a very few companies in this world, because it being an extremely niche technology and all of that. So even if you adapt the sensor and take it and modify whatever is required to it and then develop a product around with it, we are fine till the time you meet the guidelines that Kriti from IDEC just brought out, that 50% of the overall content has to be indigenous. But we are fine with that particular thing because we do understand that developing a sensor from scratch is going to be quite challenging. If you are up to it and you are able to do it, exceptional, it will be a really good product for our country. I hope I have answered your question, Madhu.
Okay, thank you, sir.
Okay.
Got it.
If there are no more questions, we'll just wait for a minute and then we'll move on to the next problem statement.
Okay.
I don't think there are any more questions. So we'll move on to the next question. Before that, I would like to thank Group Captain Pachauri for lending his time and explaining the problem statement in detail. Thank you.
Thank you, Kriti. Thank you so much for the opportunity.
Yes.
Kanav, if you allow, I'll log off.
Affirmative, sir. Thank you.
Thank you so much.
Group Captain Kanav, do we have the next nodal officer as well?
I'm just checking. Krishna ma'am, you're in the meeting.
I'm in the meeting.
Hi, welcome, ma'am.
Hi.
So we will just display the next problem statement. If you can just take some time to go through it, then we'll open the floor for question answers. Thank you. Over to you.
Okay. Hi everyone. We have floated this IDEX challenge where we want a KU band radar for drone detection. At present, what is happening is that we don't whatever radar that we have for drone detection are mainly operating in X band. So we are facing quite a lot of problem in those bands, like multiple target detection is happening, then limited range, that is what we are getting. So we want to explore the option of designing a radar based on KU band, in which initially we were looking at a range of 3 to 5 kilometer for 0.01 square meter target, but would like to get a feedback from all the companies that what is the maximum range that they can offer for KU band radar. At present, we are looking for a slightly long range KU band radar if possible. So this mainly is what we are planning to deploy. These radars are with the existing CUS solution, existing jammers. The system will be integrated with the existing jammer and will be able to give us pickup of drone which are of a very small RCS, that is less than maybe 0.01 square meter. So in this, we are looking at this, that these system are integrated, and we are planning for a IACC's type of a system where all the CUS systems are integrated, and I can see the picture of this radar sitting at any other remote location. So this is what I'm looking in the future expansion. And also we require a system which is a modular and scalable, so that whatever different technology is coming, we can integrate those technology in the same radar. So this is what we are looking out, and now I'm open for queries if you have any regarding this project.
Thank you. Anybody can raise their hand and start asking the questions.
Yes, ma'am, I have a question.
Yes, please go ahead.
Are we allowed to submit entries wherein we propose a band agnostic radars rather than KU or X band? Are we able to, deploy band agnostic radars in here?
What are these? I don't have an idea. If you can just explain this system.
Right. So you have specifically said that this would basically be targeting the KU band. So what I'm trying to imply is, are we allowed to submit entries that are band agnostic? For example, it may, detect KU and X band as well. So is that a possibility, or are we specifically strictly looking at the KU band?
So that's a possibility. Actually, what is the problem is that we are having X-band radar in our system, but we are facing few challenges with those radars. So we want to shift to other band also to see what kind of a detection they can provide us.
Understood. And you said that these would be used in conjunction with existing jammers. So are we also able to deploy our own jammers?
Sir, as of now, this project is only for the radar design. So we are not,
Understood, ma'am.
yeah, we are not looking for jammer as of now. But I'm saying in
Understood,
future
ma'am.
we can include that.
All right, ma'am. Thank you.
Any more questions?
Yes, Rishabh this side. Can you hear me?
Yes, Rishabh.
Yes, you're audible.
Okay. So I've been very interested in this specific disk challenge. So my first question is around the concept of operations. Can you throw more light on that about how this radar will be integrated in the system, and how will the whole chain of operation will look like eventually?
Okay, sir. This is what this radar will be used for the base defense of any base, since it is a limited range radar. So what we will do, for example, if in a base there is a security section, so this radar will be deployed with the security personnel chap, and we have a common area where we can see the pictures of all the CUS system. So this radar, we want its feed to come in that same room. We call it as GDCC. So in that we can see the radar, and once you are having a pickup of any incoming drone through this KU band radar, the CUS jammers which are already there in the base, security personnel will be deploying those jammer in that particular direction from where you are giving us the pickup from your KU band radar. So this is how we are going to employ this system in the present CUS grid.
Okay, just to understand the concept of operations better, one more question around this. So
Yes.
when you say that you turn on jammer once the radar detects something, do you how do you know which frequency to jam?
Sir, we are also having the RF detector with us in that whole system. So if first of all, if you are giving me a pickup only and I don't have a RF detection on that system, then I will switch on my wideband jammer. Okay. And in case if my RF detector is also detecting the same system, then I will get those particular frequency. And my jammer system has those frequencies, so I can select those frequency in my jammer.
Understood. Okay. So given this concept of operation, if I say what are the C swap parameters we are looking for? So majorly, what is the size you're looking for? What is the weight
Yes.
and the power consumption?
Weight is not much of an issue because this will be a static. We are planning to put it on a base, so it will not be a mobile system.
Okay.
You can increase the weight, but however, what we are discussing with the field, they require slightly longer range of KU band. I mentioned 3 to 5 for 0.01, but from field we are getting input that if we can increase the range of KU band and we can play around with the weight, even if it is slightly heavy, it will be okay, but we require a higher range of KU band for a small like 0.01 meter square target.
So when you say heavyweight, is it fine to assume that you are not at all looking at portability?
As of now, no sir, portability will not be an issue. It will be fixed at the base.
Okay.
Yeah.
And should I assume that the minimum range that you need is 3 kilometers?
No sir, if you can maximize it between 15 to 20 kilometer, if it is
15
possible.
to
Yeah,
15 to 20 kilometers for RCS 0.01
will that be
is
possible? If not, then
no.
what is the maximum range you can give us?
Okay. So whatever mathematics I have done in the past few days regarding this challenge, I can I can only think of going up to 4 kilometers, given the size of the challenge and the timelines in which we have to do this. I think 4 is the maximum which I can think of. I don't know if other experts have more views on this. That's
It's
why I
okay,
was
sir.
asking for
Uh,
coming up with a minimum range also.
yes, sir. I only told you the point which we are getting from the field side. That they are asking for if we can get a slightly longer range radar. So whatever is the maximum range you can offer us.
Understood. Understood. But okay, I think this is something still a bit confusing because everything that will go into designing, we from the very first hand, we need to know what's the range we are designing for. So, I mean, maximum, I don't know what's the limit to maximum here, but typically, if we compare it with the companies in US which are making over-the-shelf available radars, um, most of them are around 3 to 4 kilometers in KU band. Otherwise, it goes very. Then the question becomes on the cost constraints. So, given that this challenge falls into 1.5 crore category, uh, I'm not sure if anything under less than 3 CR will be able to get us to more than 4 kilometers. That's all my point is.
Okay, sir. Sir, whatever is the best in that 3 CR, you should give it to us. We have already decided around 3 to 5. It was just
Mhm.
that from field we were getting this input. That's why we asked this that whether more than 5 is possible or not.
I just want to clarify one thing from Air Headquarters. The project is listed under this category. The maximum spark grant is 1.5 and the minimum matching or more contribution from the industry. So we expect that if at all
Any power consumption?
sorry, I just want to clarify. So 3 CR, if you want to put it objectively, is not a upper ceiling for the project budget.
Hello.
Yes, Mr. Rishabh, could you hear me? 3 CR is not a upper ceiling for the project budget. If at all the project requires maybe a little more project development budget during the
Okay.
D&D, the same cost can be borne by the innovator. And as a part of the procurement policies, same amount is amortized to the innovator when the procurement takes place.
Fine. Fine. I understand that makes sense. Okay. So, network is a little poor on my side. Uh, was there any response regarding the power constraints?
See, we expect that the any system which is supplied, it should either work on two things. It should have a own DG set which is supplied along with to provide necessary power supply in field, or secondly, on the commercially available power supply, it should be able to run if it is deployed at our premises.
And additionally, you should be able to give us a UPS also in case we are shifting from commercial to DG.
Okay. Understood. Any requirement on the field of view of radar in azimuth and in elevation?
Whatever maximum you can give us, please, Kannan.
So we've stated something in elevation, which is a minimal requirement. In azimuth, we didn't state anything because it is expected that radar would provide 360-degree coverage.
Okay. In elevation, there is no such number.
We've put that it should provide minimum 70 degrees
Okay,
coverage.
okay, understood. Got it. Yes, 360 for azimuth.
See, azimuth we didn't state because azimuth was assumed that a radar would provide us, a defense radar would provide us a 360-degree coverage.
Okay. Understood. I was asking because to know if I make an ASA panel, so that would be a 90-degree sector roughly. Also, is there anything preference on ASA versus mechanically rotating radar?
See,
Sir, ASA is preferred. If you can design this in ASA, that is obviously preferred.
Eventually, is there any cost constraint?
Sorry, Mr. Rishabh, you were saying something? Last query you were saying?
Is there any is there any number on angular accuracies of the target which will be acquired?
See, what we will do is based on whatever technical solutions are received, the best possible technical solution will be taken forward. So, till such time proposals are being made, we didn't want to specify accuracies. Otherwise, the solutions which we get will get tied down to those values. But whatever
Okay, fine.
best possible accuracy is offered and most technically advanced solution will be taken forward for D&D.
Okay, final question on the cost side of it. So, is there any cost constraint?
No, for initial design and development from IAF side, there is no cost constraint which is put on the proposal.
Okay. Okay, understood. Understood.
I have one more question, please.
Please go ahead.
Sir, if a software-driven sensing approach were to be introduced alongside as existing deployed hardware, integration would naturally be a challenge from an administrative perspective. How would how would such a concept typically be evaluated or accommodated?
No, I have not understood the solution which you are saying.
So I'm basically saying if a software-driven sensing approach were to be introduced now, ma'am has already told us that this would be integrated with a pre-existing deployed hardware. So introducing a software-driven sensing approach with the existing deployed hardware, integration would clearly be a challenge. From an administrative perspective, or how would you accommodate such a concept typically or evaluate?
For normal integration of any hardware which is like additional radar sensor which we procure, there are standard ICD protocols which we introduce to the innovator who is working with us, so that outputs of their equipment is kind of given to us in those same ICD protocols. So there we have not faced any such challenges of implementing the integration of new equipment onto our existing frameworks. But other than that, I have not fully appreciated what you have said in terms of software-based sensing.
All right, so I'll try and clarify this a little. Basically, if some of the pre-existing sensors were to be made redundant by the use of software-driven approaches, is that something that you're open to, or is that something that's not allowed at all?
No, I have not appreciated the solution which you are proposing in terms of how do you do drone detection using software-based approach.
So these are based on pattern recognitions. There are pattern recognition models. Alongside, there are certain other concepts. We are still very much in deep research on this, but That's as much as I can divulge into it at this point of time, sir.
Noted from our end, IF side, this challenge is in particular development of radar for drone detection. So we would like to stick to that.
Understood, sir. Thank you.
Mr. Pankaj, I request you to kindly mute yourself.
Okay, one more question on this specific challenge. Eventually, what is the potential scale at which we expect the procurement to go for?
So the eventual scale at which IF will procure is worked out with the winner startup who's taken forward. Because right now it is too preliminary, we do not have the scope of solution from the industry. So to fix numbers today to a wider industry is not possible. However, it is mandatory on our part that when we onboard an industry partner for design and development prior to the contract signing, we have a number which we will say that this will be our minimum pilot order quantity, which we will procure based on successful design and development.
Yeah, from sorry.
Okay, understood. Thank you.
Sir, I have one request.
26.
Hello.
Yeah, Mr.
Please
Amit.
go ahead, sir.
Just based on
I get the contact details for any further technical queries because this is a very technologically intensive project.
So for this, just a minute.
relocate the startup.
So for any further technical queries, you can log into our website, which is idex.gov.in, and at the bottom page you will find this page wherein you can write down to us for any technical queries. We'll get back to you once we have received and consulted with the nodal officer. Any more questions?
So is this contact detail common for all the statements or for specifically for KU band radar? Is there
So
any?
this is for all problem statements. You can just specify the problem statement you are looking forward to consult for, and we'll reach out to you.
Yeah, thank you.
Now, any more questions?
This is James here. Hello.
Please, sir. Please, sir.
Is there any restriction on the maximum power that can be transmitted?
No, sir, there is no restriction unless and until only that we require this KU band radar in the defense approved band.
Okay, different subgroup purpose.
Yes, sir.
Within KU band also,
Waveforms, you don't have any restrictions.
Yes, sir.
within KU band also, are we looking at certain frequencies?
Sir, just a minute, sir.
Hello.
Hello.
Just a minute, sir.
Okay.
Sir, KU band is open.
So in KU band, we also have satellite communications going on. So is there any specific band you are looking at in KU from 12 to 18 gigahertz? Is there anything?
12 to 18. Sir, there are lots of band in which we other are coexisting with us, sir. So these bands are open for IF and other are like in 13.4 to 13.75. It is their satellites are there, but they are going to coexist with IF.
Okay, so within KU, we can choose any frequencies.
Yes, sir. Within KU, you can choose any frequency, sir.
Okay, understood. Thank you.
One question, ma'am. Last question. Where we had some issues in getting some of the phase shifters for the KU band recently for a different project. Is there any mode by which, through any channel of Indian Air Force, we can get the components?
So components from which country you require?
Recently, we had from analog devices only. We were buying from Bangalore, but this KU band we had a lot of restrictions. That's a different application we were working on. Specifically for beam steering, we were looking for a phase shifter. We were not able to get that.
So
So
we
is
can
there?
only give you a certificate that particular equipments are required for development of KU band for R&D project.
You specifically
Huh.
in IF for IF.
For IF, in this manner, we can give a certificate to you that these particular equipment is will be used for IF for a developmental project.
Okay.
Such kind of a certificate we can give you.
Okay.
No.
What do कुछ सामान अगर
What you wanted to know otherwise? Any
No,
specific
no. Is there any channel through which we can get the components for the design?
channel? That means your exemption from all those import taxes and import things.
It's not for tax. Basically, I'm from Shastra University and we have a startup. We already completed a PDF project with the DRDO. During that time, we had a lot of issues on buying the component.
No, that is
So I
fine. But can you specify that? You can drop us a mail that these are the areas where you would require, and we will just consult that whether we can help you out or in that or not.
Okay.
Right? Because we cannot be specifically targeting any particular.
we can give you. So we can give you a end user certificate in which we only say that this equipment is required for development project of IF. Some kind of a
Okay.
certificate we can give you.
Okay. Thank you. I'll drop in a mail to say my next.
So I just wanted to amplify what Bam has said. These end user certificates are provided by IEF only to the industry which starts the project work with us. Such
Yes,
user
yes,
certificates
yes.
are not
Understood.
done
Yes,
at
understood.
such
Yes,
status.
That's after the agreement is signed. We'll not know.
Affirmative.
Yes. Thank you.
Do we have any more questions? Sir, with request, can we move to the next challenge if there is no more question there?
Yes, Karthik, we can take up the next statement, please.
Right, sir. We'll display the problem statement. Sir, is the screen visible?
Yeah, it's visible.
Yes, ma'am. Over to you, ma'am.
Okay. Thank you, everyone. Now we will start the next project. It is requested everybody else, please mute your mic. This is an integrated CUS system on existing vehicle. Right now, whatever CUS equipment, whatever we have, it is it's either portable or on a fixed on a building. So in that case, whenever we are going ahead on any kind of mobility, we have to carry these equipment or carry these vehicle with us. However, at present, we have limited number of manpower to drive these vehicles and all. So we are looking for a solution in which these CUS system are integrated in our existing vehicle, that is normal Tata vehicle or 4-ton vehicle of normal carriage vehicle, where you have a RF detector, RF jammer, that is normal GPS jammers and RF jammers integrated in the own vehicle, and we are looking for a protection of these kind of mobile units up to a range of 5 km. In this solution, you can give us both soft kill or hard kill, whatever solution you can provide us. In this, we require detection by means of RF detection or radar, and soft kill and hard kill measure. In future, we are looking that these CUS equipment which are on these vehicles can be integrated in our CUS grid. That is the challenge we are looking at right now. So anybody has any query or interested in this challenge?
Hi, good afternoon, ma'am. I'm interested in this challenge. Ma'am, my first question will be, what is the range you are looking for?
So 5 km for around 0.01 to 0.02 meter square target.
Oh, okay, and both radar on and RF scanning both can work.
Yes, sir.
And it should be mounted on, ma'am, your currently
Yes, sir.
having vehicle.
Yes, sir. If required, means everything is, if going on smooth, we can make a visit to a local TRU units where we can show you the vehicles which we
Okay.
have, where
Ma'am,
you can. It's a normal.
is it sort of like the quick response team vehicle?
Yeah, something like that, or bigger than that is also there.
Okay, okay. And then do you need the system to be have its own power unit, or we can do anything, any sort of energy from
You
the
require
vehicles?
a power unit which can
Yes.
be in the vehicle only, so.
Okay, okay, okay.
So
Well, that can be can say generator unit and a battery powered, both can work.
yes, sir.
Okay, okay. This is all from my side right now. If
Okay,
anyone
sir.
has a query, they can continue.
Hello, good afternoon.
Yes, sir.
One question on this is, hello.
Yes, sir.
Yeah, one question on this is that you mentioned up to a range of at least 5 km for a comprehensive CUS system. So within the CUS layers, there might be radars, jammers. So for all those subsystems, is the minimum range of 5 km applicable, or something like, let's say, an active radar for 2 km range or 3 km range will also work on a mobile unit?
No, sir. We are looking for 5 km because at present we have system which are giving us this solution of 5 km.
Are you saying that there are
5
radars?
km includes the detection and jamming, both parts, sir.
When you say portable vehicle, are you saying like a truck or?
Yeah, I'm saying like truck, sir. Like a truck, sir.
Okay. Okay, understood.
Ma'am, one more thing I need to clarify that is it just we need to clear looking constant solution for a soft kill system, or we can have a interceptor kind of system also?
Interceptor in terms of?
In terms of intercepting the drone.
Like a kamikaze drone you are talking about?
Yes, ma'am. There is sort
I
of
don't
like.
think kamikaze drone you can set in the existing vehicle.
No, ma'am, I'm not particularly talking about kamikaze systems. We have a different solution which requires a very less space, and it is not electronic power built. It is on based on rocket motors, so it is sort of thing. if we have a constant, then we can look at that solution. But if we are open, then we want to like to pitch that solution better.
Yes, sir, you can pitch that solution.
Good afternoon, ma'am.
Hi.
Do you need any analysis or control solution also to be built inside this system integrated system?
So separate control solution I'm not looking for in this solution. I just require a comprehensive CUS solution in a vehicle in which you can give me the C2 system in the driver's seat only, where in the driver's seat I can sit and I can do all the controlling part.
But how do we decide whether to go for a kill of drone or not? How do we verify the data correctly?
So that too, it's there na in if in RF detector or in radar, if you are getting a pickup and I know if it is a drone, I will switch on, the operator will switch on the jammer, and it is up to the in fact your C2 system should give me the basically the multiple solution in how to tackle that drone, and the operator should be able to choose the best one. That is what I'm looking up for.
Some kind of processing and AI ML capabilities also need to
Yes, obviously some kind of a AI will be there in that system, sir.
Then who would decide whether we would be able to, is it a automated system or there will be an operator in loop?
Sir, it should not be a totally automated system. Manual override should always be there. So it is one operator who is there in the vehicle will be operating that system.
And you would need some kind of display unit or some kind of.
Yes, a display is required. A small C2, something like a rugged laptop type of a system, which we can just sit and control this full system with that.
For surveillance and detection, how many sensors do we require? Is it just an radar or RF detection or acoustic, or what kind of sensors?
Sir, as of now, I can think two solution, radar and RF, sir. And along with radar and RF, one soft kill jammer and hard kill solution, if you can provide me any.
And for jamming, how much frequency range?
Sir, as of now, whatever available in market is like quite wide band. If you see somewhere between 70 megahertz to 10 to 12 gigahertz, the frequencies are going. So if you can just give me that much bandwidth of frequency.
Jamming power limitation.
Sir?
Is there any limitation on jamming power?
Sir, my range is 5 kilometer. Based on 5 kilometer, you can decide your jamming power.
And for hard kill, do you look for some interceptor solution also? Or,
Sir, hard kill solution, we are keeping it as open. You can give us a solution if you are having any hard kill solution with you.
otherwise soft kill or simply jamming?
We are looking for both soft kill and hard kill. So in hard kill, if you have any solution, you can give it to us.
Thank you.
Hello, madam.
Yes.
Sir, I have few questions. First is the detection range you have mentioned 5 kilometers. What is the neutralization range? That is first question. Second question is whether the vehicle will be moving or it will be stationary, particularly for the radar. And third question is, are you looking for counter a single unit or multiple unit? If multiple unit, how many of them at a given time?
Sir, in one of mobile unit, I am looking for one or two solutions because maximum I can spare one or two trucks for this. So maximum that only I am looking for. Second is range is for hard kill, soft kill, jamming range. I am looking for around 5 kilometer. And on the move is preferred if you can give me on the move pickup. But as of now, I have not got any response from any of the company who can give me on the move radar detection.
Yes, precisely, because on the move radar is quite difficult.
Yes,
I,
so
I'm,
we are
I'm
not look as of now. I'm not looking for on the move radar detection. The vehicle will be stationary, and you will have to give me a detection and have to provide me jamming up to a range of 5 km.
Yes, madam, that I got. But the question is like, if I am detecting at 5 kilometers,
So
by the time I respond to that, let's say hard kill or soft kill, whatever, might be coming at 4 kilometer or whatever. So
the
what is
5
that?
kilometer, I am asking only for 0.1 or 0.2 meter square target. If my target size is big, it will not be at 5 kilometer. At
Mhm.
present, for big size drone, I have a range of around 15 kilometer, more than 15 in fact. So if
Okay.
I'm detecting a drone at 15 kilometer, I want an assured kill zone up to 5 kilometer. I'm specifying the 5 kilometer for only 0.1 or 0.2 meter square target.
Okay, got it.
Yes.
And just one question, madam, like, are the threats will be multiple or single threat?
Sir, obviously it will be a multiple threat, sir.
But how many? Like,
Sir, how can I decide that how many
no, I mean,
drones will attack
see,
me, sir?
right? No,
I'm
I
looking for
agree,
a swarm drone solution. So I
exactly.
cannot tell you that only one or two drone will attack me.
But that will, decide the scope of the project. Are you looking for, let's say, to engage 5 unit swarm or 10 unit or 100 unit? And
Sir,
again, the range. Yeah,
yes, sir. Maximum is how much you can give me in that particular 5 kilometer range, how much you can engage. We are just looking for, because I cannot decide how many drones will be there against us.
exactly. Yes, yeah,
It's
nobody can
like,
decide.
yeah, it's like a maximum how much protection you can ensure.
Okay,
I
so then,
understand the hard kill solution will be limited.
yeah, exactly,
Yes.
exactly.
So when my hard kill solution is finished, I have to rely only on the soft kill.
March and 27 March.
Got it.
Yes.
Yes, yes. Thank you, madam. Thank you.
Hello. Hi, madam. This is Rajat Sethi here from Qbeats. I have two questions. First, there is two part of the problem statement, as I understand. First is the pointing and tracking, and the second is hard kill or soft kill. The solution has to cover both these aspects, right?
Yes,
So
sir.
we need to do the pointing and tracking with certain objectives that you have in mind, and then initiate a hard kill or a soft kill after that.
Yes, sir.
Okay. Second part of the question is, ma'am, do directed energy, high energy pulses, and those kind of solutions are also being considered?
Sir, for DEW, the system will be very heavy.
So, ma'am, there are
What
for the
kind of
soft kill, for certain soft kill solutions, the solutions can easily fit into truck systems also.
No,
Like
listen,
the
if you're talking about the soft kill followed by a hard kill,
no, I'm
what?
just talking about the soft kill for now.
Right, soft kill
Dazzling.
is not an issue. In fact, for any kind of a directed energy weapon system, what kind of a range that you have in your mind?
So ranges also depend on what core technology. Currently, 5 kilometers upwards of that is also possible.
For hard kill?
No, for soft kill. Again, I'm talking about dazzling, sir.
You're only talking about soft kill. Soft kill is no problem.
Yeah.
Because your question itself had two parts to it,
Yeah. So the part of the question, I'll again say that whatever we are aiming for, soft kill or hard kill, if we are aiming for soft kill using directed energy based solutions, 5 kilometer dazzling capability exists and it can fit into the truck system.
No, but soft kill using directed energy is not soft kill.
So
If
there
you
are
do a
certain.
DEW, it's a hard kill.
Yes. No, we are not. DEW does not necessarily mean that you're burning it. Thermal ablation is just one of these solutions. There are a whole host of other solutions which are coming out of DEWs. Microwave, high energy pulses. There is pulse lasers of high energy running into
You're
several
talking about an
gigawatts, which can do.
EMP, directed EMP.
Directed EMP2 can be one of the solutions. Again, that is bulkier, but
then
there are
your dazzle-
smaller solutions also.
So then you have a proposal that way, no? See a DW, or let's say what you have said about right now. You said about dazzling. So dazzling doesn't stands good for a US. It'll only affect a manned flight, right?
No, not necessarily. It is going to burn the sensors.
If
It will
you
make
burn,
them-
then it is a hard kill,
It's a
man.
hard kill.
That's what I'm trying to tell you.
So again, I'll separately reach out to you. There are certain non-linear plasma impact which basically dazzles the sensors on board the drone or whatever UAS system you have, and that renders it flight unworthy.
Hello, can you hear us?
Yes, ma'am.
What we are saying that DW solution that you have, it's actually a hard kill solution. It's not a soft kill solution.
Okay, ma'am. Again, there are certain aspects of this which, I mean, we are already in touch with DG AirOps also, but we will be separately discussing this with you. Just wanted to understand that scope.
Okay, let me
if you
make
were
it-
to pursue
Yeah,
is
I'll
that within the
just
ambit
make
of
it-
this or not?
I'll just make it clear to you. If you have solutions to it, first we look for a soft kill solution. If it doesn't work, we go for a hard kill so that now we can stop it. Right. So whether you have directional soft kill or you have got something else, then you can tell it to us.
Okay.
Right.
Okay. So that opening exists that we can go, imaginative around the solutions for this, right?
Yes, sir. Yes, sir.
Of course, that be more. That is what we require, because otherwise, all your
Right, sir.
But sir, please remember that the trucks will be used for other purposes also. It will not be a totally a CUS vehicle. Understand, sir? Because we have limited kinds of trucks in our inventory. So these will be used for logistic purpose also. So we cannot dedicate a full truck to you to design your system.
So can it be defined as to the area and the swap limitations that we have so that we can then focus around it?
What
Like
we
half a truck or what?
Yeah,
Like
maybe
you'll have to define something.
maximum half a truck we can give you.
Yeah, so it can be palletized. Do you have height constraints also?
No height
On this
constraint
truck?
we
Okay.
don't have. But
Okay.
this your system should be like a foldable system.
Yes, it is palletized, of course.
Yeah.
Okay, all right. So just wanted to explore whether this lies in the realm of your acceptance or not. If yes, we will go out and propose this as well.
Okay, sir.
Thank you.
Okay.
Do we have any more questions?
Please consult your direct or
Do we have any more questions?
Yes. So, if this 5 kilometer number is for 0.1 meter square RCS, is it fine if for 0.01 RCS threads number goes a little relaxed to, let's say, 3 kilometers?
Yes, sir, we can do that, sir.
Okay. Okay, understood.
Hello, ma'am.
Yes, sir.
Ma'am, for proposals and introduction of new startups, ma'am.
Yes, sir, go ahead.
Yes, ma'am. I was looking for, means I was planning for MSMEs, and I'm now under incubation under IIT Ropad.
Hi, sir. There will be a session done by IDEX post this technical session. You can ask the process-related questions there. And this session is strictly for the technical discussion of the problem statement.
All right, all right.
Thanks. Any more technical questions?
Yeah, good afternoon. This is Ketan Bhatti here. I wanted to clarify on the RCS at 5 kilometers. Is it 0.01 meter square or is it 0.1 meter square?
So it is 0.02 meters square for 5 kilometer.
Understood. Okay.
Still 0.01 and 5 kilometers square.
No, 0.02 Kanav, I think.
No, ma'am. I'm aware of it. From statement we can bring it. I can tell DIO we can bring it up again for clarification of it. Karthik,
Yeah,
if you can.
Yeah.
I'm sorry, it is what?
Just a second, we'll bring up the problem statement so that there is nothing on your side.
Is the screen visible?
Yes, for integrated CUAS, the RCS is not spelled out in the problem statement. For the Q-band radar, it was spelled out specifically.
Okay.
So that's what we are saying, that my existing system is having 0.02 meters square at 5 kilometers. So if you are able to give me that also, or better than that, that will be my criteria.
Okay, ma'am. Understood. Thank you so much.
For just one quick question. Do you require any support on IFF also, or that is taken care of?
No, we don't require IFF in the system.
Okay. Okay.
This is to answer Mr. Ramadan's query. Sir, this 22 problem statement, you'll have to look at the calendar posted on IDEX Twitter handle of when the technical session is. Otherwise, you can fill the form for any particular question. In today's session, we cannot discuss the DIS 22 problem. Sorry, DIS 14 problem number 22. Any other questions?
One question, a little off the topic here, but as ma'am mentioned that there is already a system to detect at 5 kilometers radar at 0.02 RCS. May I know which system is this? Is this indigenous or who has developed this?
You want to know what all system IF is having?
You mentioned that there is already a radar system which can detect up to 5 kilometers for 0.02 RCS. May I know which system is this?
Sir, you can sir, we have right now, you can contact Zen Technologies for this. Right now, we have their system.
Okay, so radar is from Zen Technologies.
Yes, sir.
Okay, okay.
I hope there is no more questions for today's technical outreach.
Yeah, last question.
Please, sir.
Madam, you mentioned about integrating with existing systems. So can you just elaborate on this? What exactly you are looking for in the maybe short term or long term?
This is a future expansion that we are looking for, not in this current IDEX challenge. In future, once we are in the right now, we are not in a process, but in future, when all these CUS system are integrated together to give a common picture of a wide area, that time this system should be able to integrate with the existing system, like all on a common platform. in which we will be providing you the ICDs, and your system should be able to join the main server sort of thing that we are planning to design.
Okay, understood, madam. And is it possible currently, like, yes, you mentioned you already got radars and everything. Is there a possibility that we can have those feed additional to whatever onboard detection we have?
So
And
why do you
then
require those feeds?
I'm not getting
Because
that.
because these vehicles will be the mobile vehicles. They will not be near to the existing system. They will be, going and will be deployed near border area. So our radar right now, no radar is there at border area.
Okay, so
So
the distance will be too much in between them.
yes,
Right?
yes, sir. Yes, sir.
Okay, got it.
Excuse me, ma'am. This is Preetham from QAxis Motor. I have a question regarding detection. So the detection of these threat drones need to be done using only radars, or can you use a system which has like a visual sensor, like a thermal sensor and a EO
For
sensor?
thermal sensor, the ranges will be very limited. So that's why we are only looking for radar and RF detector.
So then it necessarily has to be like a soft kill. If you want to do a hard kill using a directed energy weapon, we
Sir,
should
I'm
be
not
able to
suggesting
see
a
visually.
directed, sir, I'm not suggesting a directed energy weapon. I'm just suggesting that a hard kill solution can be provided with this. So, hard kill solution can be provided uh, with, initial input from radar or RF. And after that, you can have, the hard kill system can have their own detection in form of EOIR sensor. Hello.
Ma'am, you're audible.
I think Mr. Preetham was the one who was asking me question.
I got
Yes, sir. So you require a separate EOIR system with your hard kill solution, sir.
I was just wondering, can we just provide a system which has EOIR and a hard kill system? I mean,
Yes, sir. We are
we'll
right now
integrate
just
it with
looking
somebody who has
for.
already run the radar system.
Yes.
Do we have any more questions?
Sir, how will work on the bigger problems, sir, like autonomous vehicles and trucks?
So we are having trucks. We will give you the trucks and you design the system on that.
All right, ma'am. All right.
Yes.
So, ma'am, the previous question remains unanswered. Like, if you already have the radar technology with you with ranges of 14, 15 kilometers also, why do you want us to again develop that?
Sir, whatever technology I'm having, those are not portable solution. I
Got it.
cannot fit it on a existing vehicle. That is my problem.
Okay, got it.
Yes, sir.
Then this earlier problem statement 54 KU band radar, if we have that along with a jamming system, will it not comprise of this problem statement 63?
Sir, I'm not getting what you want to say.
I just want to clarify in terms of solution being sought is see all our mobile elements which get deployed in the field in types of operation, they go out and they do not have any protective cover, which is a holistic protective cover against the drone threats. So what we intend to do is that whatever vehicles we have in our convoys, we want to convert few of those vehicles which provide us drone detection while on the move. Drone detection in terms of detection, in terms of soft kill, in terms of hard kill. So you may find that certain pieces of solutions being sought in problem statements may fit in here. However, here we have one binding limitation that our vehicles which are available with us are fixed. So we want to utilize those vehicles to provide protection to the convoy or to the radar or to other mobile elements which go out in the field. So that is a primary requirement of the whole challenge which is being discussed now.
So can problem statement 54 be a subset of problem statement 63?
See, that problem statement previous one, Ku-band radar, doesn't exist at all today. So if problem statement 54 is developed, along with that, it will require all that thing to be developed in shape, size, form factor, which has to comply with the existing vehicle. So that might become too binding on that problem statement.
Yeah.
So that is why we are dealing them that Ku-band radar itself is a developmental pathway. So we put it as a different problem statement. And integration of counter UAS solutions onto vehicles, which is a holistic solution, which is not only detection, it is detection, soft kill, hard kill, all means so as to offer protection on the move. So hence, this is a separate problem statement.
But in future, it both can be combined. In case if we can find a compact solution for KU-band radar.
So IEF will not mind that solution. We'll be more than happy to take it if better detection comes on the existing vehicle. That will not be limiting for us.
And do you need any ECCM capabilities also to be?
We're able to hear you strength 2 very low.
Do you need any ECCM capabilities also to be incorporated in this solution?
So basic ECCM techniques are available in the radar. Whatever is the existing ECCM techniques that are available in the radar, we require that.
And can it be like clubbed with some existing interceptor solutions like Akash or something?
But what
No,
can
our scope of solution is pretty well defined. It's an isolated system which goes out along with the mobile element which is going. We are not looking at integration of such a solution with any other system today. It's
Okay.
a future scope and not for today.
Okay. Yeah. Thank you.
So with this, we can close today's session. For any more technical,
There's one more question. Do you need any integration with? Yes.
There's a little echo. Can you repeat? We need integration with?
Either GPS or any other GNSS solution.
Sir, the jammer which you will be providing me will be a RF jammer with plus GPS jammer. I think the jammers which are available right now, they can jam dual thing. They can jam RF signal also. They can jam GPS and all other frequencies also. So we require that system.
It's not just jamming; it's the positioning of that particular system with respect to like the whole system. I hope the truck may be having the GPS, its own GPS, but do you need a similar solution to be available with this system also?
Sir, if you can provide me thing like, but on the radar or the radar which you will be providing me, it will be showing me the pickup of that particular track, and on your C2 I can see the location.
Because along with the drone locations, we also need to a certain location of the counter drone system.
Sir,
Since it is on moving truck.
yes, sir, on the move, can you detect a system?
Like at particular timestamp, we can have the location of this truck, which is mounting this system, as well as the location of the drones in order to affect the anti-drone countermeasure.
Sir, you can give the solution along with your proposal.
Yeah. And as well as the interceptor, even if we have anything, it should also have some GPS kind of location information.
Thank you.
Sir, you can provide this in your whatever you are offering us, you can give us in your proposal, and we will evaluate, and if required, we will include that.
Do you need any data recording also, data recording and playback, or it should be on real time only?
And sir, data recording facility should be available, na? If I'm intercepting anything later on if I want to replay the set, I need to have some replay facility available with me.
Yeah, because problem statement doesn't give all these details.
Sir, we have not finalized the PDS PRU right now. So
Yeah.
whatever solution you will be giving us, based on that, we will be making the PDS PRUs.
Yeah, thanks.
Okay.
Do we have any more questions? Please note that the screen, if you can see the screen, you may please log into our website, idex.gov.in. There we have at the very bottom, we have our grievance or technical query part, wherein you can submit all your technical queries related to the challenges. And post we receive it, we will be sharing it with the nodal officer, and after consulting, we'll get back to you on those technical queries as well. So if any of the queries is unanswered, you may please reach out to us using the website. With this, we may close today's technical session. Group Captain Kanav, do we have the permission to wrap up today's session?
Yes, please. Thank you. I think you will continue with your own outreach. Me and Sudeshna ma'am will be logging off. Thanks.
Right, sir. On behalf of IDEX and every innovator, I thank all the Indian Air Force officers, the nodal officers, for the technical session. Thank you so much, sir. Thank you so much, ma'am, for joining.
Thank you.
Thanks. Logging off.
So, dear participants, as I already mentioned, you may please log into our website as well for any technical queries. If it is unanswered, we'll definitely get back to you on that. Post that, I just wanted to request, is there any, apart from the technical side, is there any more queries you have regarding the application or anything? The floor is open. You may please ask the queries and we'll answer it.
Yes, sir. Sir, can we approach the problem by forming a consortium of 2 or 3 companies?
Sir, you can have as many MOUs or partnerships you want, but an applicant to IDEX should be one company, and the contract shall be only signed with that one lead company.
So, are there any constraints on?
Yes, consortiums are not eligible for application, sir. Either you have to be a startup, an MSME, or an individual innovator.
Okay.
Any more questions? All right. So we would just like to say that request you to please send in your proposals before the last date. We are dealing with a large set of problem statements this time, and there might be a lot of on the last day. So it's better to submit on time. That's it from IDEX team. Thank you everyone for joining in. Logging off now.